Alright, hello everyone. In this little video, I am going to talk to you about distillation. It would help if I had my better microphone plugged in. And alright, so let's talk distillation. Now this is kind of over pages 8, 9, 10, 11 in your Unit 2 packet. And first let's just talk about what distillation is. Distillation is a method of separating a mixture of liquids. And how it works is based on a difference in boiling points. So if you kind of look at that picture, we have our distillation setup, where on the left in that, this is probably Queen's favorite type of glassware, Queen the band. We have a round bottom flask filled with a mixture of liquids. We start heating it, and guess what? The liquid with the lowest boiling point is going to start boiling first. So it's not like every single liquid in there is boiling, just one of them will start to boil first, and it's going to go up, and then it's going to travel through what's called our condensation tube, which is jacketed with cold water. We call it a condensation tube because guess what? It's going to cause that gas to condense back to the liquid phase. So again, first liquid boils off, goes into our condenser tube. It's going to condense back to liquid, and then over here at the end, we're going to have pure liquid. Again, the liquid with the lower boiling point. And if we measure the temperature as we do this, we can actually see this process happen. As a substance goes through a phase change, again, if we were to record that temperature here, if we were to put a thermometer right there, if that temperature starts staying constant, that tells us that we have a liquid going to gas. We have something boiling off. So we can actually identify a substance by looking at our distillation curve. Because again, that flat region of temperature where our temperature stays constant, that is a phase change. That is a liquid turning, or I should say that's a substance turning from a liquid to a gas. So as I look at my curve at the bottom of page 8, I notice that I have that flat region right about 70 degrees. Well, guess what? That's going to tell me question number 1 on page 8. There's definitely hexane. So again, as I look at this, because I have my flat part of my curve right here, that corresponds to my boiling point of hexane. So hexane's in the mixture. And then look at where my next flat portion is. Close to 100 degrees, again, is where I have another phase change happening. So that tells me, okay, when I go and look at my table, I definitely have heptane in my mixture. So for question number 1 on page 8, we definitely have hexane and heptane. And then number 2, which ones are not? Okay, well, if we take a look at it, it's hard to say much about acetone or methanol because our boiling point, our temperature never goes there. We don't know if it just passes right through. But as we keep going up, definitely not 2-methyl 2-propanol because look, there is no boiling point at 82 degrees. And it is, honestly, it's tough for me to say about toluene or 1-butanol because it's not like we keep heating our mixture. I guess we could assume they're not in our mixture of 2 liquids, but again, we definitely know not 2-methyl 2-propanol because again, at 82 degrees, there is no flat region of our curve. Let's try a couple more. So page 9. So number 1, referencing our chart, identify the material present in the mixture that has the lower boiling point. So again, let's look at this. And maybe about 70 degrees here. Is this phase change happening? So let's look at that table. And looking at our table on page 9, hexane is the substance with the boiling point about 70 degrees. Okay, so let's go to our next flat region. Identify the material present in the mixture that has the higher boiling point. Again, the flat portion, the flat part of our curve represents a substance boiling. So that temperature, maybe about 110 degrees roughly. So let's look at our chart. And taking a look at our chart on page 9. Toluene has that boiling point of about 110 degrees Celsius. So that second substance must be toluene. And then number 3 asks, what materials could still be present if it's still being heated? So again, if we look at our temperature, sorry about that, it started right down about 20, we're up to 110, so anything below, or really anything before or with a lower boiling point than toluene, we know is not in the mixture. Hexane is and toluene is. But as we look at our table for acetone, there's no plateau at 56 degrees, so there's no acetone. There's no plateau at 65 degrees, so there's no methanol. There's no plateau at 77, there's no plateau at 82, there's no plateau at 100 degrees. So we know we don't have ethyl acetate, we know we don't have 2-methyl 2-propanol, and we know we don't have water. If we were to keep heating, maybe we could discover that we still have 1-butanol present. So for number 3, maybe still 1-butanol. Okay. I am going to maybe complete these questions here, but maybe see if you can answer them on your own, and then I'm going to go through and come up with my answers. So maybe pause the video and see how you do. Again, I'm going to read my answers in 3, 2, 1. Okay, so for number 1, as I look at this table, how many different compounds are there? Well, I see, pens being a little, I wish I could back out of that, pens being a little not nice today. So let's try something else here. I see maybe 2 plateaus. That's really thick. There we go. So I would say that there are 2 components definitely in the mixture. The lowest distillation temperature, I would mark that as this temperature here. It is maybe about 70 degrees. And I just realized I missed one. Oops. Okay, let's backtrack. Let's go with probably three substances present. We have a point right there, there, and there, where the graph is kind of flat. So our lowest temperature, I would say, is about 56 degrees. And that's going to be in Celsius. That corresponds to acetone. Next compound, maybe a little over 80 degrees-ish. And that would be our 2-methyl 2-propanol. And then number 4, last boiling point looks to be about 100 degrees. And it looks like that compound would be water. I'm sorry about that little mix-up there. Sorry about my pen going crazy. There's 3 flattish portions, so that would tell us with page 10 we would have 3 components. Again, when we look at a distillation graph, everywhere that the graph is relatively flat, that is a substance undergoing boiling. So we find the temperature, match it to what we know, and that's going to identify the substance for us. One last thing on page 11, and that's sketching. So we are asked on page 11 to sketch a distillation curve. And obviously mine's not going to look nearly as nice as yours. But we are told that at time 0, we're starting at about 20 degrees. And we have 3 components. We have 2-methyl-2-propanol, which has a boiling point of 82 degrees. We have butanol with a boiling point of 117. And they're told that we have methanol, which is going to have a boiling point of 65 degrees roughly, 64.7. And it tells us that we want to make the plateau for each component at least 3 minutes. So that tells us we start at 20 degrees. We start to heat the substance. So the temperature is going to rise steadily at first. And it's not going to plateau until it gets to 65 degrees. So that means our temperature, and maybe ignore my scale on the, actually we could probably put a scale here. So again, our graph is going to steadily rise until we get to our first boiling point. So we get to about 65 degrees. Our methanol in the mixture is going to start to boil, and our temperature will stay constant. And let's hold that for about 3 minutes. Okay, good, good, good. Once all the methanol is boiled off, guess what? Our mixture is going to boil, is going to shoot up. Its temperature again will increase. And it won't plateau again until it gets to its next boiling point. So it'll go up until we get to 82 degrees. And when we get to 82 degrees, our 2-methyl-2-propanol will start to boil. Our temperature will flatten out. It's all going to boil off. Once it's all boiled off, guess what? Temperature starts to go up again until we get to our last boiling point for the butanol, which is 117. And then at 117 degrees, our butanol will start to boil and our temperature will plateau again. And so this is what our final distillation curve would look like. Again, key thing to remember, class, is if we have a substance present, remember the graph is going to flatten as it boils off. And if we don't have that substance, as we're heating it up, again, the temperature is just going to increase. It's going to pass the boiling point of the substances we don't have. It only plateaus at the boiling point of substances in the mixture.